Good morning, my YouTube viewers. Crystal here. I just wanted to make you another video because I wanted to show you what happens when you have a logistic regression function that you make from scratch and compare the logistic regression function that was made from scratch to the SK models, logistic regression, and stat models, logic. And what I did was I got the code from another website, and I'll just read to you the website. It was https colon, I think it's oblique beckernick.github.io oblique logistic regression from scratch oblique. So that is the website that I got the inspiration for this homemade logistic regression function from, because obviously I don't know enough about statistics and I don't know about programming to make my own logistic regression function. So I had to borrow a logistic regression function from somebody. But I will say that this article that he wrote, he predicted on the training set, and you're not supposed to predict on the training set. You're supposed to predict on the validation set or the test set. So he didn't do it entirely correctly. But having said that, he did give some good code that I was able to modify to put in the Kaggle Titanic program that I've been working on. So what we're going to do is we're going to use the Kaggle Titanic dataset to test out this homemade logistic regression against sklearn and then stats models. So now what you have is you have three types of logistic regression that you can use on the Kaggle Titanic website, and you can use it on any data set that is a binary data set. So without further ado, we'll go ahead and do the code review now that I told you where I got the inspiration for this from scratch logistic regression function, because I didn't make it. I don't know enough about statistics, and I don't know enough about programming to make a program like that myself. So I had to be inspired. I had to borrow somebody else's work. So the first thing that I did was I created my program. I created my program on Google Colab. The nice thing about Google Colab is it's free. It's a free online Jupyter notebook where you can write code. And I will say that it's a lot easier to write code today than it was 30 years ago. And the code was written in Python. So what we'll do is we will go through the problem statement of the Kaggle Titanic website. Problem statement is: the sinking of the Titanic is one of the most infamous shipwrecks in history. On April 15, 1912, during her maiden voyage, the widely considered unsinkable RMS Titanic, after colliding with an iceberg. Unfortunately, there weren't enough lifeboats for everyone on board, resulting in the death of 1,502 out of 2,224 passengers and crew. While there was some element of luck involved in surviving, it seems some groups of people were more likely to survive than others. In this challenge, we ask you to build a predictive model that answers the question, what sorts of people were likely to survive, using passenger data, name, age, gender, socioeconomic class, etc. So that's our problem statement. So we've got to pick the survivors. So the first thing that we're going to do is we're going to import our libraries. The nice thing about Google Colab is many of the libraries are already installed on the Jupyter Notebook, so all you have to do is import them. So we've imported Pandas, NumPy, Matplotlib, and Seaborn. Then we load our data sets. The data sets have come from the Kaggle website on the Titanic competition, but I put the data sets on my personal GitHub account. So you can see the train file. See, it's a combination of numeric and categorical columns, and these numeric and categorical columns are going to all have to be converted to numeric columns before we can do any work. So this is some information about the train file, and it tells you which columns are categorical and which columns are numeric. So we check the test file. The test file is similar to the train file, except that it does not have a survived column, because the survived column is what we have to predict on. So we check the information on the test file, and you can see that the test file is very similar to the train file. So now we just check the gender file. That was the file that came on the Kaggle dataset that you could use it to submit your work, just to give you a little bit of experience submitting work. And the reason why is because the Kaggle Titanic competition is the first competition that people can enter, because it's the easiest competition they have. I will say that I personally had a lot of difficulties the first competition that I did, because I knew nothing about programming in Kaggle. I knew nothing about Jupyter Notebooks. I knew nothing about submitting my work. And what I had to do is I had to look at the work of other people. And finally, after about much trial and error, I finally figured out the sequence of events that you have to go through to actually make a program. But I had to look at a lot of people's programs to do that, and quite often they weren't following a logical sequence of events, which made it very difficult. So what I'm doing is I write my programs in a logical fashion. I know that I'm not winning competitions, because in order to win a competition, you have to code yourself. You have to do your own code. And obviously, I don't know enough about coding to code myself. So the people who are winning these competitions, they know how to code. And specifically with the Titanic data set, because you've got the survivors mixed in with the non-survivors, generally the people who score 100% have gone and researched these survivors and have written their program for the survivors that they have researched. And strictly speaking, that's not really the way you're supposed to be doing it, but it does give them some good programming experience, even though strictly speaking, they're not supposed to do it that way. The next thing that we do is we check for any null values, and so we have 3 columns in the train set and 3 columns in the test set that have null values, and these null values are going to need to be imputed. So what I've done is I filled the null values. The numeric columns I filled with median, and the categorical columns I filled with mode, and I did that in both the train set and the test set. So now we have a graphical representation of our target, which is the survived column, and you can see that there is a mild class imbalance. Another graphical representation just using group by. So now what we're going to do is we're going to pre-process the data. And how we pre-process the data is we have to convert the categorical files to numeric files, and we do that by using an ordinal encoder. And in addition to that, some of the columns, I wanted them to be integers. So some of the columns, such as age and fair, I converted that to integers. So we've got a heat map, if you like looking at heat map, to compare the independent variables to the dependent variables. There's a heat map if you like looking at that. And the next thing we do is we set up our X and our Y values. So our Y value is train.survived. Our X value is train.drop, passenger ID, survived, name, cabin, ticket. Our X test is text.drop. Our passenger ID, name, cabin, and ticket. There was no survived column, so we did not have to drop that. So now you can see X, and you can see Y, and you can see X test. So now what we do is we split the training file up for training and testing. So X train, X val, Y train, Y val equals train test split, XY test size equals 10%, random state equals 1, stratify equals yes, shuffle equals true, and we checked the shape of these columns as well, these data frames as well. And then what we did was we put the data on a scalar. So scalar equals standard scalar fit X train, and then we transformed X train, X val, and X test. So we wanted to count the values in the validation set. The validation set, you had 55 that were 0 and 35 that were 1. So that means 55 people perished and 35 people survived. We set up the class weights because you can use class weights in logistic regression and also other types of functions within sklearn. So now what we've done is we've applied our PCA. So PCA is something that I was working on previously, and I applied the PCA just so I could get a nice diagram. So what we did was we set the PCA up components for 7, and when you set the PCA components up for 7, then that actually negates the PCA. Because if we go back here to where our X train, Y train is, it's only got 7 columns. So if you set PCA up for 7 columns, it's almost like you're not using PCA at all. Because the purpose of PCA is to sacrifice, is to get rid of some of the columns. And so you'll sacrifice a little bit of accuracy, but it'll work a lot better. And then because it's working a lot better, in theory, it's going to be more accurate anyway. But we just, that was just PCA. So we set PCA set up to 7 is as if there's no PCA anyway. So now what we're going to do is we're going to set up our homemade logistic regression. And as I said, I personally didn't program this because I'm not proficient enough to do it. But I borrowed I was inspired. This code inspired me to put the logistic regression in the Titanic dataset. And I did have to make some modifications to get it to work. So we set up the sigmoid function, and so this sigmoid function is that's the basis of the logistic regression, because the sigmoid function creates a curve that's like an S. So if the answer is below a certain value, then it's going to be 0, and if it's above a certain value, it's going to be 1. So the answer in logistic regression can only be a 0 or a 1. And that is what your sigmoid function is all about. And then we define another function called log likelihood, which is going to be used in the logistic regression function. And then we define our logistic regression function that's got lots of information in it, and it sets up the weights and it does lots of neat things. So what we do is we define our weights, but because this program was written in Python 2, their X range hadn't been defined. So what we did was we just made X range range. And then so we set up our weight, and you can see the weights. So the next thing we had to do was we just predicted on the training set just to get the accuracy of the training set. So the accuracy of the training set was 80.27%, which is higher than the accuracy of the training set with sklearn's logistic regression. And then what we did was predicted on the validation set. And when we predicted on the validation set, we got 75.56%. We put it on a confusion matrix, and we counted the prediction or YPRED, and you had 63 zeros and 27 ones. So they're saying 63 perished and 27 survived. But when the Y val is 55 perished and 35 survived. So when you put it on the confusion matrix, it tells you, what is the true positive, the false positive, the true negative, and the false negative. And that's why you only got 75.56%, because it said people perished when they didn't perish, and it said people died, but people lived when they didn't live. And that's why you have a low percentage. The reason when we come to the end of the video, I'm going to show you a diagram of how the actual examples are fit in with each other, and they're all interspersed together. And because they're all interspersed together, it's difficult for the program to pick them out. So it's always a good idea to make diagrams, because if you can make a diagram, then you can get a better idea of why you don't have a very good accuracy. And that is, when we get to the end of the program, you'll see the diagram and you'll see why we don't have a very good accuracy. So we created a data frame where we compared our actual values against our predicted values. And then we predict on the test set, but I have no way of calculating the percentage unless I put this on the Kaggle website. But I'm not going to put it on the Kaggle website because the predicted score on my validation set is not high enough for me to spend all of that time to do it, because I've got I think about a 77 or a 78% on my leaderboard as it is, and I'm just thinking, well, I'm not going to get a really low percentage just to test this out. We're just going to test it on the validation set and not worry about the test set. So we prepare our submission so we prepare a data frame, and then we convert that data frame to a submission file. And then we take that submission file and we view it so you can see what the survived is. The next thing we look at is logistic regression from sklearn. So sklearn is a very good library. It's easy to use. It's a good library for novices, and I will say that I like using sklearn because it is an easy library to use, and it gives lots of examples, and it really helps you a lot. And when we trained and fitted our training set, we've got a 79% accuracy, which is less than what we got with the homemade logistic regression function. And when we predicted on the validation set, we've got a 72.22% accuracy. And I was reading about this, and the reason why you don't get as high in accuracy on sklearn is because their parameters are a lot stricter. But if you set the, supposedly, if you set the parameters up like a high C, like a C is a high and then penalty equals none, then supposedly it's supposed to increase your accuracy. But I tried that and I didn't get anywhere with it. But you can always try to make your penalties none and give it a high C and see if it increases your accuracy. So we put it on a confusion matrix, and then we compared the examples in the YPRED. So we had 60 who perished and 30 who survived, compared to YFAL, which is 55 who perished and 35 who survived. So again, that's not a very good score. And then when you put it on the confusion matrix, it's not a very good score either. And we put that on the data frame, so if I wanted to submit it to Kaggle, I certainly could do that. So now what we're going to do is we're going to predict on X test, and that is actually the test data set. And so we predicted on X test, we put it on a data frame, and we made our submissions. And if I was going to submit this work to Kaggle, this is the data frame that I would be using. But I'm not going to submit it to Kaggle because the score is not really high enough. It's not a very high score, so I'm not going to do it. Because the way that I have to do it with Kaggle is I have to copy and paste all of the code from Google Colab or GitHub onto the Kaggle Jupyter Notebook, which I'm not really keen on doing because it takes a lot of time for me to do it, and then I get busy doing other things, and that's my problem. I get busy doing other things. And now what we're going to do is we're going to check the logistic regression from stats models, and then in stats models it's not called logistic regression, it's called logit, and it's coded differently. It's coded differently than sklearn. So sklearn is a lot easier to use than stats models. Stats models is more for people who are working on statistics and economics, and in addition to that, it's written more like R, and I don't program in R. So I wasn't able to get the score for training and fitting on Xtrain, but you did get a summary. So if you like summaries, you can look at the summary, and that'll tell you all about how the Titanic performed on stats models logics. So now what we're doing is we're predicting on the validation set. So y hat equals logic.predict xval, pred equals list map round y hat, pred equals np array, pred dtype equals np int64. So we check our accuracy, and we had a 75.56% accuracy, which is the same accuracy that we had on the homemade logistic regression. We put it on a confusion matrix so you can see the true positives, the false positives, the true negatives, and the false negatives. And at some point I'm going to have to make a blog on how to read a confusion matrix. And the next thing that we do is we print off our counter pred. We put the pred on a counter, and you can see that there's 57 who perished and 33 who survived. But in the YVal, which is the validation set, you had 55 who perished and 35 who survived. We put that on a data frame. And then what we do is we make predictions on our X test. So we just, instead of xval, we put X test in this formula. So y hat test equals logit predict X test. Prediction equals list map round y hat test. Prediction equals np array. Prediction dtype equals np int64. And then what we do is we put our predictions into a data frame, and then we convert it to a CSV file, and then after we've done that, we put that into a data frame, and we can submit that CSV file to Kaggle. So what I've done is I've designed this program so you've actually got 3 CSV files in my Google Drive. I've got a CSV file called HM submission, a CSV file called SK submission, and then a CSV file called SM submission. So I can see right here I made a little mistake. It says right here SK submission, and it shouldn't be SK submission. It should be SM submission. So what that means is that if I did actually try to submit it to Kaggle, it wouldn't give SM submission. It would give SK submission. So that's a little error that I have found that I need to work on. I'll do that when I finish this video. And the next thing we do is we do visualize PCA 2D, coming to the end of the video, so I'm not going to go through the code. I'm just going to show you the diagram. This is the diagram where the zeros are all mixed in with the ones, which is why it's difficult for the computer the function to predict accurately, because you've got the zeros and the ones interspersed, and there's no clear line of demarcation, so it's just doing the best it can to predict. And then here's a 3D diagram of it, and again you got it all interspersed, and because it's all interspersed in there together in memory, it's difficult for the computer to actually predict properly. So we're coming towards the end of this program, and I found a mistake that I made that I'm going to have to correct before I go any further. So I'm going to conclude this program. I hope you got something out of the program as I did a code review. So thank you very much for watching my video. If you like my video, please like, subscribe, and share. If you like the work I'm doing and you want to make a donation, I have my email address to my PayPal account in the description box down below. I do not have enough subscribers, so the only way that I can make any money on this channel is to ask for donations. And thank you again for watching my video, and I look forward to making new videos for you.